Okay, everyone. So in this video, we're going to look at using the derivative to find an angle of inclination, but we're going to do the reverse of what we did in part one. In that part, we started with a curve and a point, and we had to find the angle of inclination that the tangent at that point made with the horizontal. Okay. In this video, we're going to do the reverse. We're going to start with an angle, and we need to find the x coordinate this time. Okay. So we're going to start by just graphing the curve. So it's going to look something like this. Okay. So this is the formula that we use to find the axis of symmetry of a parabola. Okay. And if we put the numbers in, we're going to get something like this. So x equals, and it's going to be -3 over 2. Okay. So the coefficient there is 1. So it's going to be 2 times 1 is just 2. So our x value is -3 over 2. So to find the y value, which will give us the coordinates of the vertex, so to find the y value, we're going to substitute x equals -3 over 2 into that equation there. And we'll get something like this. So we'll get 3 over 2 squared. So -3 over 2 squared is going to be 9 over 4. And then it'll be plus 3x. So it's going to be minus 9 over 2. Okay, so I've just done 3 over 2 times 3. So it's -9 over 2. And if you evaluate that, I won't show all the working, but if you evaluate that, you'll end up with a value of -2¼ Okay. So that's our y value. Okay. So that's going to give us a vertex of -3 over 2 and then -2¼ And let's just have a look at what that's going to look like on the axis that we've got over here. Okay. So we've got -3 over 2 is going to be somewhere around about there. So it's -1½ And then we're going to go down to -2¼ So around about, it's like about there, okay? And if we draw the parabola now, it's going to go through -3. So I'll try and draw it like this. We'll go through there, and there's the vertex, and then we're going to go up, and we go through the origin like that, okay? So that's it. And what I might do is just draw in the vertex, or label the vertex, sorry. So it's going to be minus, and I'll write it in this form. It's a little bit, I think, easier to see. So -1½ And then we've got -2¼ Okay, so hopefully you can see that. I know it's a little bit unclear, but yeah. Okay, so what we need to do now is find the x coordinate for the angle of inclination of 22, or the tangent that has an angle of inclination of 22. So I'm just going to try and show you what that'll look like. So let's just choose a random point. Okay, so I know this isn't the right answer, but let's just choose a point here. Okay, and I'm just going to draw a really rough tangent. Okay, so just pretend this is a straight line that goes through the point just there. Okay, it touches the curve just there. All right. So this is the tangent. It's a straight line. And the angle of inclination that we're looking for is going to be the angle just in here. Okay, so it's going to be that angle there. And we know that that angle is 22. Okay, I know that's not 22, but yeah, just bear with me. It's also, to make it a little bit easier to see, it's also going to be that angle. Okay, so these two angles are the same because they're parallel lines, that the x-axis and that one that I just drew there. So we're trying to find, yeah, the x coordinate that's going to give us a tangent that has an angle there of 22 degrees. Okay. And to do that, we can use a little bit of calculus. Okay, so we're going to go, I might just draw that, make it a little bit easier to see. So if we differentiate the curve, so it's going to look something like this. So the derivative is going to equal 2x plus 3, okay? And what we can do now is we can actually work out that the angle we're after is 22 degrees. So we can go 2x plus 3 equals, and it's going to be the tan of 22 degrees, okay? And if we just do a little bit of rearranging here, we're going to end up with something like this. So x equals tan 22, and it's going to be -3. I've just subtracted 3 there, and then divide all that by 2, and that's going to give us the x coordinate. And if we put all of that into a calculator, we'll end up with a number. I've written it down. It's -1.297 986. Okay, and there's a bunch of decimals after that. Okay, so that's pretty close. We're pretty close to the final answer. And what it's saying is that the x coordinate that we're after is -1.29. So it looks like it's going to be somewhere down here. Okay, so sorry, it's very rough, but It's going to be somewhere down there. And if you draw a tangent at that point, okay, that's going to give us an angle in there of 22 degrees, okay? And we just need to now give our answer to four significant figures. So what we'll do is we'll rewrite this. So we're going to go 1, 2, 3, 4, and then draw a line. And if you're not familiar with this, I made a video just a few days ago about rounding to significant figures, and I went through this technique. So maybe check that out if you're not sure of what I'm doing here. So we go 1, 2, 3, and we stop at the fourth one, okay? And I'm just going to write 1.29, and we just need to work out whether that's going to be a 7 or do we have to round it up. And I look at the next number, which is 9, which tells me I'm going to have to round that one up, okay? So my final answer is approximately minus 1.298. Okay, so that's the x-coordinate that's going to give us a tangent that is inclined at an angle of 22 degrees to the horizontal.